This conference will now be recorded.
Hello everyone, welcome to our day 18 in our GCP Cloud Architect training, where yesterday we looked into the various options for Cloud SQL, because that's one of the important thing. For example, for any website, for any kind of an application, right? A database is very, very important. That's where we looked into various stuffs like having a two-tier architecture, an example for that, and then how do you do a migration? May not be the sophisticated migration demo which we have seen, but a basic one at least to give you a thought how you can use Google Cloud Storage and uh, some other tools to do the migration is what we saw. And we also saw the what's the best option to access your Cloud SQL instance using an internal IP address. So, and also we shed some light on how we can do um, migration from other clouds, from other databases like Oracle, all those things. So what are the options which we have? With the limitations of the offerings in GCP, what you can do is what we saw yesterday. So that's the end of Cloud SQL module. Now let's go to the next part. So a lead for that is uh, yeah. So just a quick time to think this thing. So the first question is something like this. Uh, MySQL data volume. So in your on-prem is around 60 terabytes. Uh, this needs to be migrated from on-prem to GCP. The database is MySQL. Very clear. If you want you to assume a version, you can assume it as 5.7. 5.7 is the database version, uh, which is available in GCP, but the volume is 60 terabytes. How do you migrate this? What could be the options which you can think of, folks? And please change the mode to private or to only to the presenter so that everybody can think. Hope the question is clear. We have 60 terabytes, MySQL 5.7. Specifically, if you want me the version to be provided, 5.7. How do I migrate from on-prem to GCP? Maybe to make it very, very simplistic, take it as a one-time migration itself, like exactly like what we did last Sunday. What could be your thoughts, folks? How will you achieve this? 60 terabytes having a transfer appliance is an overkill, is what I would say. Need two MySQL instances, then how will you address it? Mm, so two instances, so but how do you address it? So now if you have two systems, you are trying to do horizontal scalability. Now you have to manage that which data or which table should be written in which instance. That's going to be some kind of a sharding, right? You have to do that. Yes, Cloud SQL has a 30 GB of limit. That was the whole intent why I just put this question. So straight away going for okay. So some of the option which Anil B mentions is something possible. So 30 to 60 terabytes. Yes, Deepak also is correct here. So if it's just the 60 terabytes, which we know we cannot support it on Cloud SQL instance because that is the limit which they have put. We cannot do anything beyond that. If you have a paid account in GCP, you can go check it. Even there, it is the same. So that's the limitation. No distinction between a paid account or a free trial account. So in this case, we have to rely back or fall back to our best bet, which is our virtual machine. So simply create a virtual machine. Now 60 terabytes. Now your take whether you want to use, say for example, a transfer appliance for this or not. You take a call. But if you go back to the cheat sheet which we have created, um, real implementation cheat sheet, we had created the chart, right? Just look into that. 60 terabytes is your data. How long does it take? So if we do that, we will it does not require is what I feel. So let's just verify it. So mm, so if I take something like 60 terabytes, oh sorry, 1 minute. So somewhere between 10 and 100. So if I use, say for example, 1 Gbps connection, 1 Gbps connection, it can be in 12 days. So somewhere here, so you can use transfer appliance in this case if you want. The only thing is that it's going to take time, as Anil B is mentioning. It can take time. So if you want to do it in a chunk of 1010 or something like that, even with 100 Mbps or with 1 Gbps connection, you can do it. So that's a good thought. So transfer appliance could be used to get the data. Uh, and have a SSD disk. Now we know SSD disk, each disk can take up to 64 terabytes. We have seen this in our virtual machine class. So one disk is good enough to handle it. Good. So that's the first option. So you may use transfer appliance, but I feel it could be little expensive. Who knows if it's not in um, Asia and you don't have this option itself, but possible to use. You can get the data to Google Cloud Storage. You take a call, but the question was more towards how do we, after bringing the data to GCP, into what system we will load. That was the whole intent. But it was good that you also thought, how do you bring the data? People like Anil B thought about that. That's good. Moving on to the next question, folks. MySQL data volume of 80 terabytes needs to be migrated to on-prem. Now this was specifically put 80 because I know one disk can take only 64 terabytes. Now what will you do now here, folks? What can you do here? 80 terabytes. Volume is increasing. That's natural. That's what do we expect. Yes, uh, Anil Kumar. That's a good option. Yes, Vivek. That's an option. Good option. So create a disk of, and why 16 GB specifically? Was there anything, Mangesh? 16 GB, why was that? So let me give a minute for others to think also. Correct. That's the limit. So the option is, yes, Vivek, that's the limit. So what you can do basically here is, you can do something like this, folks. Create two disk to handle if you want. You can do it. And or to be very frank, instead of two disk, I would say uh, looking at the documentation, right? Looking at the documentation, what they mention is maybe even 60 terabytes, what we saw uh, in reality could be a little tricky, I would say. So per machine, right? If you just look into the documentation, per machine you can have 128 persistent disk, but each disk can only take 2 terabytes of size. Now for example, here itself, right, 60 terabyte option which we were thinking, uh, it could be something like, it looks like it is a possible one. We need, I've never tried it, to be very frank. So based on what we have seen in the console, I have added this as an option. But option one itself, in reality you may need something like 30 disk is what I feel, because this is what the documentation says. To be very frank, I have not tried it also. So if I just go here, search for GCP machine types. So if I take any machine type, They mention what is the max each machine can handle with respect to the volume wise. CPU, they mentioned that somewhere. 1 minute. Here. This is what they mentioned. So for example, okay, instead of E2, let me take N2. If I take N2 series, if we just go with the documentation without even trying it, the option which I can think is, look at this documentation, folks. So what they say is N2, let's take slightly a better configuration, N2 standard 16. So what you can go is you are going to have 16 vCPU, 64 GB of RAM. So the maximum number of persistent disk is 128. Not SSD. Forget about SSD or HDD. It's going to be persistent disk. It's going to be maximum is 128, and the maximum total persistent disk you can have is 257. That is the max you can have basically. Um, that that is the max. You cannot go beyond in one machine. So with that in background, what you can think is, in this option, have just one disk which is 64 terabytes. Do it. In the second option, you may have something like two disk, but some DBA needs to do some extra work between syncing the data between. So something like in MySQL or most of the databases will get an option which actual disk you need to write. So maybe something of that sort has to be done, but it's not a straightforward one. Remember it. So the whole intent here is we are not looking into the database perspective actually, we are looking from the infra perspective. So what can be provision? So this 2 TB per size is not Google saying, but I'm just giving a small hint here. So if you want to say, for example, if you attach it 128 disk, each disk can be usually 2 terabytes. Just doing a small math may not be true is what I would say, but it's not that 128 into 64. Don't do that math. That's not going to work because the maximum total persistent size for one virtual machine is 257 or 56 terabytes. Okay, so the whole intent was I wanted to show that the limit per disk which you have is, sorry, per virtual machine which you have is 128. So we had seen this in our virtual machine, but again wanted to re-emphasize it here. So hope this is clear, folks. Hope this is clear. This 2 terabytes is just my understanding. If you attach 128 totally to a powerful machine, each disk can only be 2 terabytes maximum. But if you attach two disks, that's okay. 64 you want to attach, that's okay. The last option, need an horizontally scalable system with multiple masters or write nodes. So in your option 1, option 2, you were having only one master. It was one single virtual machine. But the moment you need horizontal scalability, meaning there should be multiple masters or write nodes, what would be the option which you can think of? I need to write something into a virtual Cloud SQL instance in Singapore and also in Belgium, something like that. What would be the option? Which we have not thought of. Read replicas will not work because it's going to be only read. Failover will be only in the same region. Again, it's not going to work. So horizontal scalability will not be a good choice. You can use managed instance group, then you have to do it yourself. You have to do it yourself. So if you see the managed instance group, the demo which we saw, it was for a web application. Now what we are talking is a database. So now you have to use a concept called as sharding. You have to use a concept called as MySQL sharding if you assume the database is MySQL. So just search for MySQL sharding. You'll see good amount of materials, but a DBA is going to be something a best fit to do that part because it's not more from the infra there, because adding identical nodes, but the syncing part, all those things, it's going to take really a good hands-on experience required, and it has to be from a DBA. So that's the reason if you will cross the limit of uh, sorry, Anil, I did not understand what's that. 2 into 256, so 2 into 128 will cross the limit of So it's going to be 120, 256 only, right? It's going to be 256. Yeah, 1 TB is still there. So in this case, as Vivek mentions, instead of relying on the same product, why don't you think something better? So if you have a requirement like this, Spanner could be a good choice, which we have not looked into it, but we in the beginning we just saw a high level overview. It is another database, transactional database, which Google offers, and this is a proprietary product. So you can think this entire time to think option is as a lead to the next module. Why should you think slightly different from Cloud SQL? So if the volume is slightly high, or you need a horizontally scalable database, adding more nodes whenever you need, a better choice is to use a product called a Spanner. So let's look into what is Spanner. Okay, so what is Spanner in a very simple terms? It's a horizontally scalable relational database. So most of the time when you see a relational database, they are vertically scalable. You have everything in one single powerful machine, and you do every write operation into that machine. So but having a relational database which is horizontally scalable, meaning add more nodes. So when you have a vertical scalable system, you will always have a technology limit. At that point of time, what are the number of how many transistors you can have in a processor? That processor will have a limit of how much vCPU and memory you can have. You're always going to have a technology limit. But when it comes to horizontally scalable system, you keep on adding identical copies. It could be a commodity server. That's where Hadoop became a hit. So you don't need to have a very powerful system. You can have commodity servers, right? Very cheap servers you can, but you can have identical copies of it, n number. Now when you go with an horizontally scalable system, there's no technology limit. It's the limit is only your budget, how much you can afford. Can you have 10 nodes or 20 nodes? 20 nodes is your upper limit because that's your budget. That's your credit card limit which you can use. Then that's going to be your limit. So there's no technology limit when it comes to horizontally scalable system. That's one important thing which you need to remember. So that's what Google offers, a horizontally scalable relational database. So you can use it for transactional purpose, any kind of a banking application, any kind of a ticketing system, logistics, where transaction is very important. That's where the Spanner comes into picture. And just for your information, if you use an Android phone and if you have ever installed an app from Play Store or purchased an app from Play Store, it means you have used Spanner, because all the transactions behind the scene in Play Store, Google Play Store, is handled by Spanner. So it's something like a battlefield tested app, because Play Store also has a billion users who accesses it. So people who use Android, more than a billion users. So definitely they would have done some, bought an app, rented a video or a movie or something. So definitely they would have used Spanner. So Spanner is the database which is behind your Play Store for any transactional purpose. Now, what is Spanner? All those details before we look into. Let's take a step back. Why Google? And this is a Google's proprietary product, folks. There are talks where they are planning to create an open source version of it, but still not there as per my understanding. We may expect an open source version of it sometime soon, basically. Um, so the first thing is, before we look into Spanner details, let's take a step back and understand how a relational database works, a traditional relational database. So when it comes to traditional or a traditional database, relational database schema, you say I want a table with data types, like it should have a table which is like 4 columns. The first column should be of integer, second column should be string, the two remaining columns should be float or a boolean data type. So you mentioned that a table with only 4 columns, the schema is strict there. You cannot change the schema later. If you want to change it, you have to change it for the entire table. Add a fifth column, for all the rows you have to add it, basically. So it's very strict. You don't change the schema on the fly in a database. Strictness is there, and that is sometimes important for some kind of an applications like banking. So that's really good with a relational database. SQL, you know SQL, ANSI SQL language, structured query language, like how people know Python. There's also a querying language for database, structured query language. If you know something if you have worked on MySQL, for example, tomorrow if you want to work in Oracle, you can do it. 60 to 70% most of the work you can do it, and there could be something very specific to Oracle that you can learn, but your base is there, because even Oracle is SQL compliant, so it supports the language SQL. You can write everything like how we were doing yesterday, select, star, update. It works in every relational database. That's another beautiful feature which you get with a relational database. The next part is consistency. So what do you mean by consistency? Basically, before we understand consistency, most of the relational database will have an option called as ACID. They are ACID compliant. So what is ACID compliant? A stands for atomicity. So let's take a very simple example. I'm transferring a money to my friend using a net banking application. So when I transfer money, right, it should be atomic, meaning either transfer it fully or don't transfer it. Just save transaction failed. Don't have a partial transaction, meaning if I transfer 100 rupees, 50 rupees should not be transferred and 50 rupees should not be in my account. So it should be either minus 100 in my account, minus 100, and in my friend's account it should be plus 100. That is called as atomic. It should not be something partial. So for example, if you have uh, read those Ramayana and Mahabharata, you would have heard of a story called as Trishanku. It should not be like Trishanku, basically. So not even the earth, not the heaven, in between. So it should not be like that. Basically, that is the concept here. It should be atomic in nature. So the next part is basically consistency. C stands for consistency. So what does that consistency means is I transfer money, it gets transferred to my friend. Now I go and check it anytime, it should be there. It should be reflecting the consistency. Now, say for example, if I morning, if I go and log into the net banking, it shows minus 100. Evening, if I go and say it does not show minus 100, it shows uh, nothing. It should not be like that. It should be always consistent whenever you look into it. That's one thing. Why this consistency is very important is, if you just look into any social media, right? I also have a YouTube channel. I usually keep a track of how many likes I have got for each video. One time when I log in, it shows 10 likes. Second time when after sometimes if I go and log in, it shows 9 likes. Why is that? Because the database used to keep a track of all those likes is a different database. So the transactions are not, it's going to be eventually consistent. It's not strong consistent. But if you take money related stuffs, the moment I transfer money, it should be, it should show, yes, it is transferred or not, and it should show that consistently. But if your Facebook like, your YouTube likes, it will vary. So after the video becomes stable and after a week or so, if you see, it's going to show always 10 likes. So it would have synced everywhere across the world, and it's going to show, because the reason is why sometimes in my Facebook or in my YouTube videos it shows 10 likes, sometimes it shows 9, is maybe when I hit the request, it would have hit a different server where the data is not synchronized. So but when it comes to relational database, it's very strong, consistent. So the moment something has occurred, the transaction occurred, it's going to be reflecting everywhere. So another example, an opposite of strong consistency is eventual consistency. For example, if you're storing likes, that is one example where you're okay, 1 or 2 likes less is okay. Similarly, the population of a country or a city, if you're trying to keep a track of that, loading that into a database, uh, eventual consistency is okay. So you don't need a very strong consistency. But if it's all banking, you always expect to have a strong consistency there. So that's where relational database really shine. So they have some good qualities. Now what are the bad qualities, or what is that they don't really shine? is availability. So they don't have a high availability capability. What they can do is basically failover, which we saw yesterday. So that is the max they can have. They can just provide a failover option. Scalability wise, they're always vertically scalable, meaning you make the same system more powerful every time, which indicates basically you will have a technology limit at one point of time. So for example, in GCP, you cannot have a Cloud SQL instance more than 96 vCPU, 624 GB of RAM. That's not possible. That's the upper limit, at least as of today. When I started, it was 64 vCPU, 426 GB of RAM or something. So at least now they have increased it to 96. And if you see something like in AWS, it could be 128 vCPU. That could be possible. But nobody can go beyond certain limit. It's going to be a technology limit. So those are some of the drawbacks, some good features of a relational database. So like your MySQL, Postgres, Oracle, Microsoft SQL Server kind of databases. So coming back to the C part, atomic, we understood that Trishanku example. If you understand, you can easily remember it. Consistency, whenever you do it, it should reflect. It should be always there. It should not be that morning it reflects, in the evening it's not reflecting. It should not be like that. I stands for isolation. Assume I transfer money to my friend and you transfer money to your friend. Both should be isolated. It should not be that the amount I transferred, it goes to your friend, and the money which you transfer, it comes to my friend. It should not be like that. It should be isolated. So two transactions should be isolated. That is again something easily supported by uh, relational database. The last part is durability. Data, how durable the data is. What if my database crashes, or there is a LAN cable plugged out, the disk failed? Now if you recover everything and boot the system back, the data should be persisted there. I should be able to see, yes, Mahesh transferred X number of rupees to his friend. ABC transferred Y amount of money to his or her friend. That should be shown. It should be durable in nature. So these are something usually people called as asset compliant, which is usually supported by a relational database easily. So they have some good features. They have some features which is not really good. Coming to a non-relational database, what is a non-relational database? For example, where you don't deal with usually a structured data. It's going to be little semi-structured data. So something like a JSON kind of files. So here the content is going to vary every time. It's going to vary every time. Say for example, data coming from an IoT device. Let's just take a simple example. You have mounted two IoT devices on the highways. One of the highway is in Shimla, where the weather is always little cold, and it can sometimes snow or it can sometimes be rainy. And you have another uh, 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 IoT device which is mounted in a place which is very hot. Now, two different same device which has the capability to capture what is the traffic congestion, what is the weather report. It has that capability. The IoT device has that capability. But the data which comes, for example, if I just open it, so let me just put to normal mode. So I have IoT sensor 1, IoT sensor 2. This is placed in a place like Shimla, where it is, or Switzerland, whatever you want to take. It's a place where it is little snow, rainy, all those things can happen very easily. And the other one is in a place where it's always most of the time hot. So now this is going to, and these are mounted on the highways. Now sensor one is going to say it can send some telemetry information like traffic, uh, traffic congestion. It can send that details, weather, um, like okay, raining or something. If it's raining, how much centimeters of rain it has captured. So centimeters of rain. Now this one, it's going to capture definitely congestion. And we usually, when we mount any device on the highways, it is usually, it's not going to capture what is the temperature, whether it's very hot or sunny, if I'm not wrong. uh, Rain is usually captured, is what I have seen. The reason is, if rain occurs, there's a chance that traffic congestion can increase. So that's the only thing. If it's hot, usually congestion will not happen. So if from sensor to this field is not captured, and both the sensor information or the telemetry information should be stored in a table called as sensors. Now, one row, assume only one data came. So from sensor one, so traffic congestion, yes. Then raining. So if I have the column like sensor traffic congestion, it's a Boolean field. Then raining, centimeters of rain. If you have something like this, raining is around 2 centimeters of rain. This is from sensor 1, and sensor 2 is going to send traffic congestion, yes, but these are going to be empty because that's a place where even rain will occur very rarely. So if you see such kind of a stuff, right, maybe you don't need this information itself, but if the devices are coming, if the information is coming from various resources, basically you want to put everything here. So the schema sometimes may be required to change dynamically. You need to add a new column, snowing also. So this kind of a stuff on the fly, if you wanted to change the schema, the best bet is always to go with something called as a NoSQL database, where you don't have a strict schema. You want you add a new schema, change the schema of your table. So that's where a no relational database, a NoSQL or a non-relational database comes very, very handy. For example, MongoDB, if you have heard of this, MongoDB is a good example there. Cassandra, these are some good databases, which is usually a NoSQL database. This is one drawback. Schema can be changed on the fly, but sometimes it could be an advantage also. But the schema is not fixed. Remember that. I can change it. We'll see that demo in our class itself. SQL. This is the biggest drawback, I would say, with your NoSQL database, because MongoDB, the way you query it is going to be different. Apache HBase is going to be different. Apache Cassandra is going to be different. So every NoSQL database will have their own querying language. So it does not mean if you learn one NoSQL database, you can query others. That's not going to work. So you have to learn every time. The learning curve is there. So you have to use different querying language. Consistency wise, they are going to be eventual consistency. That's where these likes, population of a country kind of information are stored. So eventually they are going to be consistent. So in runtime, if you're going to see like live, it may not be always up to date. So maybe after a day or two, if you see, the data is going to be synchronized everywhere and you should be able to see it. So that's going to be eventually consistent. So when it comes to high availability, availability, they provide a high availability. The reason why they can provide high availability is they are horizontally scalable system, meaning I can add n number of nodes, 3 nodes in Singapore, 5 nodes in London, maybe 4 nodes in US Central, and the data needs to be synchronized, needs to be kept synchronized. That's where this consistency part comes into picture. So it's going to take time to synchronize, and that's where if you hit a request, maybe this time it would have hit the server in London, where the information is not updated. The like shows as 9, But if you again refresh it, maybe the request now goes to Singapore, where the likes are updated, it's going to show me 10. So if I again refresh it, it may again hit my London, it's going to show me 9. So eventually it's going to be consistent. So if you just leave it for a day or so, and if you look into the videos or the post, Facebook post which you have put, it's going to show like 10 likes or 20 likes. And it is horizontally scalable, meaning I keep on adding nodes, I can scale it very easily. So these are some best benefits or best features which you get with a NoSQL database. So, and what Google thought is there's some good features with relational database, these things. There's some good features with no relational database or no SQL database. Why don't we merge it? Why don't we merge it and get create an hybrid out of it? So that is where they started a new product because they had this kind of tech, and to be very frank, whenever Google launches anything, they would have faced this kind of a problem for their end user products like YouTube, Gmail, Maps, all those things. They wanted to come up with a solution. Later, when they feel that solution can be used by the entire world, they provide it as a service. That's how they usually do. Basically, Hadoop also came from the same angle. So they had an issue. They started working on it. Then they released it to the open source community. So thinking on the same lines, they came up with a product called a Spanner, which can be a merger of both. So schema wise, everything is good. Scalability wise, everything is good. So a best feature which you can get. So best of your relational database and a non-relational database is what you get. And just a fun fact, uh, doesn't it look like a marriage between these two things or a dating between these two products, non-relational and a relational? So just a fun fact, Spanner was launched on 14th of February. 14th of February 2016, if I'm not wrong. So the 14th of February, Valentine's Day. So it was just a small fun fact. Just wanted to share you that. So it's just like a merger between, or a dating between, or a marriage between these two best products, and have a new product which can do everything. So that's your Spanner in a simple terms. It's a relational database which has all the capabilities of uh, a traditional relational database like consistency, schema, SQL compliant, and all the best features of a NoSQL database or a non-relational database like high availability and scalability. A merger of both. When you do that merger, what you get is a no compromise relational database. Why I call it as no compromise? All the relational schematics are going to be there. Schema, asset transactions, ANSI SQL 2011, all those compliance is going to be there. All those things are going to be supported. Horizontal scalability, you're going to get a service level agreement for uptime for which is up to 99.99, 5 nines of availability, and this entire stuff is fully managed. You don't need to have a DBA to manage this schemas, all those things. Everything is going to be, most of the thing is going to be fully automated. So only if there's some issue with performance or anything, DBA may come into picture to fix it. Otherwise, it's fully managed. So what do you mean by SLA of 5 nines? This is what usually architects usually talk. At least the enterprise architects, they will say, I want an uptime of 5 nines. What does that mean? What does that mean is if you just go to this website, uptime is, it's going to show you if you just mention 3 nines, 5 nines, 5 nines of SLA indicates every day Spanner will never go down itself. Weekly it can go maximum 6 seconds down. uh, in a month it can go only 26 seconds down, folks. This is very, very important. And the stuffs which we have seen like virtual machines, all those things, they can provide something like 3 nines, which means every day they can go 1 minute 26 seconds down. You cannot ask Google why it is down. That is the acceptable agreement between you as a customer and Google. But if it goes beyond 1 minute 20 seconds, then they will compensate you in the invoice which you get. So if you have an SLA of 5 nines, basically in the entire year it can go only 5 minutes down. And usually in any cloud, this thing, right, the SLA is always provided not at an yearly level, but they provide it at a monthly level. So if there's a breach, the cloud provider should provide a compensation. Usually it's going to be in the form of a lesser invoice. Maybe simple example, uh, this is March, right? So in February there's no issue with Spanner, so you'd have paid X number of dollars. But in March there was some issue where more than 26 seconds it was down for a day or something, in a day or something in March. So your bill is going to be less than the X dollars which you paid last time, assuming everything is the same, no further changes in your infra. You're going to pay a lesser price because they compensate. They compensate that they were not able to fulfill the SLA. So that's something which you need to keep in mind. So that's something which you get with Spanner. Now a small comparison, now you may slightly get, now it has all the features of a relational database, then why should I use MySQL? Why can't I use always Spanner? So this is where a small thumb rule comes into picture. A small comparison is, if you have two cars, one is a normal car, which say for example something like uh, a budget car, basically like Maruti Suzuki kind of a stuff, or any low end car, and you have another car which is like BMW, something of that sort. Which car will you use for going to buy a glossary? Assume that you go buy it, you don't go order it, but you buy it. Usually people will prefer to use a budget car, right? So they will go use a budget car and buy a glossary. But if you are going on a long ride, which is going to give you which needs comfort, all those things, definitely people will prefer a posh car for a long ride. It is the same thing. So if you have a requirement which is a normal database requirement, and the volume of the data, maximum, no minimum requirement, maximum is 30 terabytes, go with Cloud SQL. And you don't need horizontal scalability, all those things. Cloud SQL is a good choice, either MySQL, Postgres, or Microsoft SQL Server. There's no minimum limit. My data can be even 1 GB or less than that also. I have no problem. You can use that. But when it comes to Spanner, right, there is a minimum limit. There's no upper limit. Minimum is the volume should be more than 2 terabytes. That's very important. If you keep it less than that, the ROI, return on investment of running the Spanner instance, is not going to be there for you. You can keep it, no problem. You are not going to get the full benefit of it. The reason is, this is an expensive product. So use the expensive product only when you have a specific need. So the same example. So don't use your posh car to just go a kilometer or a mile to buy a glossary stuff. So that is the way you should use it. And as a cloud architect, to be very frank, I have never implemented a Spanner stuff. Most of the implementations were on SQL. Most of them were on Postgres actually. Uh, uh, Whenever I get an opportunity to work on Spanner, right, first of all, I don't directly go with Spanner. The reason is it's an expensive product. I can share you some experience with Spanner when I was learning it. Uh, First of all, you should ask the requirement whether Spanner is really required or not. I'm not saying that you should always avoid Spanner, but there should be a genuine reason for that. So ask what kind of application it is, whether you need a global consistency across the globe, where you want to have something like um, a global call center, where a person in, say, for example, in Thailand or Bangkok finishes the details, the call details, and updates it. Then a next person in Belgium opens up that same record, should be able to continue. That global consistency, if you need it, then Spanner is going to be a good choice. And the volume is so high that you want to basically handle, which cannot be handled by your Cloud SQL instance, then Spanner is going to be a good choice. The global consistency is required always. So if you have that kind of a requirement, then only go with Spanner. I need an horizontal scalability also, then go with it. Otherwise, just because um, you have just because you want to try it, don't go with it. So doing the due diligence as a cloud architect is always good. Uh, See whether it is going to be helpful or not. And Spanner is going to be charged hourly rate. So I'll show you that during the demonstration. So use a rule of thumb. So this is not a standard one, but the rule of thumb which is used is minimum, folks. This is not maximum. So maximum is going to be in petabytes. It's an horizontally scalable system. You can go up to petabytes. Keep on adding nodes. You're going to get more volume which you can handle. So basically, minimum should be 2 terabytes. Then only you are going to get a return on investment. This is a rule of thumb. Now, what's the best fit? When should I use Spanner? Basically, if it's a database, a relational database like what we saw in Cloud SQL, any traditional one, a e-commerce website which has only a presence in a specific country, something of that sort is going to work. But if you have a global supply chain management uh, or a global call center, where, as I mentioned, somebody updates the ticket in one country, the moment his or her shift ends, the other person in a different country can start working on the same ticket in that call center. It should support that. So if you need something of that sort, then it's going to work very well. Or these days, many people provide, or many organization provides online gaming, and in that online gaming you will have something called as a leaderboard, where you will see, you can play with people across the world, and you can see who is leading the game, who is the leader in the this thing. So if you want to create something like a leaderboard, Spanner is going to be a good choice. Or any logistics, transportation like FedEx. If you were to do that kind of a stuff, it's going to be really helpful. So it has to have a global presence, basically. If it's not, I would prefer to use something like a Cloud SQL instance itself. Um, in another case where I would use Spanner is basically, I don't need a global presence, but the volume is very high. Volume is very, very high, something like 100 terabytes, only accessible in India. Then what I will do is I'll create a spanner, a regional spanner instance in India itself. I don't need a global presence, but only a regional presence, but the volume is very high. Maybe I have migrated from Oracle, from on-prem Oracle to GCP, and the volume is 100 terabytes or 120 terabytes, something of that sort, more than 30 terabytes. Then I would prefer to use Spanner. So these are the places where you use Spanner. So far, we saw all good things about it, but I strongly recommend, whenever you look for any product, right, you have to look always for two things: when you should use it, when you should not use it. Then only you will have a better idea as a cloud architect. So when you should not use it, where Spanner is not a good fit, this is the important slide, I would say. Because if you know everything is good, then when you should not use it, I usually ask this question even in some forums or anything. So I usually ask it. That way you'll know when not to use it. The first thing is, you should never use it for lift and shift. What do you mean by lift and shift? The demo which we did uh, last Sunday and tomorrow yesterday, basically we had a data in MySQL in my local machine. I used MySQL dump and exported it into Google Cloud Storage. From there I did it. I did not do any changes to my system. Lifted it from my on-prem, shifted it into GCP. It worked. But Spanner is not a good fit for lift and shift. Why Spanner is not a good fit for lift and shift, folks? Any reason why? Any thoughts? Why it is not a good fit? Is it expensive because of that? Or is there any reason why it's not a good fit for lift and shift? Any thoughts, folks?
I mean, we're not updating every time, right? I mean, it's a one-time kind of activity, right? Lift and shift is
Okay. Okay.
the spanner we can use only when we have a global systems, online processing. There we can use more cloud spanner. Lift and shift, lift.
Okay. Okay. But I'm expecting something better. Uh, it goes to, don't go too technical. Always stick on to a very simplistic thing. It may help you out sometimes. Lift and shift. what do you assume when you do lift and shift basically? We will screw the limit, we will use the limitation of the features. No, no. It provides no change in application. No, you should not use it for lift and shift kind of a migration. Basically, that is the recommendation which Google mentions. Uh, then exploring the full nest. Simple, folks. When you want to do lift and shift, what is your expectation? You should have a Spanner instance in on-prem, right? That is when you will do lift and shift. Uh, you had a MySQL instance in on-prem, you lifted and shifted it to GCP. It worked. But can you have a Spanner instance in on-prem? First of all, no, right? So if you cannot have an on-prem instance in, on-prem instance, Spanner instance in on-prem, what is the question of lift and shift comes into? No customer in the world will have an Spanner running in on-prem. So they may have Oracle. So but they will never have Spanner because it's a proprietary product. At least till date, it's a proprietary product. So you don't have that product itself running. So what is the, you will not use that itself. So Oracle with the high volume is only the data which is the case which you will use Spanner. Now Oracle, the schema, the internal stuffs, all is going to be different, and your Spanner is going to be totally different. Now, without doing the change at the schema level, I cannot migrate it. Meaning it's not a lift and shift. So I have to do some refactoring. Then only I can do it. So it's not going to be easy. So that is why they say if it is a lift and shift kind of a requirement, avoid Spanner or change the requirement. It cannot be lift and shift. It has to be basically modernizing or refactoring. So you have to involve a DBA who knows Spanner, how Spanner works, how Oracle works. The person changes it, or maybe there could be some tools. And Google also has something called as professional service. Google professional service who really have done such kind of stuff. And if you search in net, you will get good amount of success stories where people where Google has done Oracle to Spanner migration. So that is the reason you should avoid this for lift and shift. So that's the reason I told stick on to your basics. Lift and shift. You should have something in on-prem. Only if you have something, you can shift it. If you don't have anything, or if you have totally a different product, then it's not going to be lift and shift. Okay, so that's the first use case. You should avoid it. The second use case is at least when I started my career in 2005, I worked on an application which was an e-commerce application where it was using Sybase as the database. All the business logic, right, uh, was written in something called a stored procedure. So, and triggers. What is a stored procedure? Groups of SQL statements compiled, kept in the database for faster execution. So you don't run every time a single query. So you basically compile it and keep it ready. Whenever you want, you call it. So that's your stored procedure. Trigger in databases whenever something happens. Meaning, a very simple example, if I reach a minimum limit in my bank, less than 1,000 rupees, then it should automatically trigger me a email. So this kind of logic, you may say this could be written in an application better, but at least in the beginning days, right, many people used to write something in database. I personally have written it in database because people felt writing it in a database is going to be a very secure option. uh, so if you are having lots of business logic in the database via store procedure, triggers, user defined functions, then Spanner is not a good choice. Now this is a very polished way of saying Spanner will not support triggers. Spanner will not support store procedures. So two ways of saying it, but how you want to put it, you can use it. So if you are doing something from Oracle to GCP migration, so most of your schemas can be changed to Spanner equivalent, which involves a DBA. Plus, if there's any business logic written in Oracle, usually in Oracle they write it in PLSQL. So what you should do basically is it needs to be rewritten in the application side. Maybe if your application is going to be written in Java, transfer or convert all your business logic into so business logic which is in database to a logic which is written in your application. Now you have to involve an application developer also. So in that kind of a case, avoid spanner, or if you cannot avoid it, you have to make it very clear during the assessment itself. This requires these many DBAs, these many application developer. So that's another point where you should avoid spanner, or be at least alert the customer that this requires something more. The key part I would say as a cloud architect is mentioning how many days or how long this entire implementation takes. So look for those things, always keep some buffer. So I do that. The next point is whenever you have a latency requirement, where it is something like you need to get response in few microseconds or milliseconds, one digit retrieval time, one digit millisecond, like 6 milliseconds, 10 milliseconds, then again spanner is not a good choice. It's going to give you response in few seconds. So if your latency requirement is very very low, you cannot do that. So basically these are some cases where you should avoid spanner instance. So spanner instance, I like such slides because that gives us an idea when not to use it. Most of the slides, if you see most of the major training materials, they say this is good, this is for good for these things. But what is it not good for? That is also should be important, right? So now what we'll do is we'll do a demonstration, folks. We'll do a demonstration on Spanner once we come back from the break. Regarding the demo, right? I would leave it to you whether you want to try this demo or not. You take a call. If you just want to see the demo, you can just see the demo and you don't need to try it. The reason why I'm saying this demo, you can do it or no need to do it, is basically it's more towards database. That's one thing. The second one is this product is charged per hour. The demo, we are going to finish it in 10 minutes. It's not going to be a big demo. It's going to be a 10 minutes demo only. Even if I use it for 10 minutes, I'll be charged for 1 hour. It's not like your virtual machine where the billing is per second. This product is slightly different. So they are going to charge it for an hour. It's a premium product, so you cannot expect per second billing and all. So it's going to be a per hour billing. So even if I do a demo for 10 minutes, I'll be charged for 60 minutes. The very traditional way which you have seen where AWS started their journey. So their EC2 instance and all were per hour charged. Later when Google came, the innovation of pricing came, they were also forced to do billing like per second billing. So um, so it is, the spanner billing is still going to be per hour billing. So when I was doing this one, right, for the first time when I was learning spanner, what mistake I did was I created a spanner instance and I forgot to delete it, and I was using a free trial account. So in 3 days or 4 days my entire trial account was exhausted because it was so expensive. So I guess $1 or $2 is what it cost. So 2 into 24, or 1 into 24 roughly, it's going to be around $40 or $24. So 3 days, 4 days I left it. I had already utilized some amount of credits. So in 4 days, everything is gone. Now I go and create a VM. It says your credit is exhausted. So you may do that mistake of creating an instance and forgetting to delete it. So I don't want you to do that mistake. If you are very cautious, the moment you finish the demo, you delete it, you can do it. Okay, so it's your call whether you want to do this demo or not, but at least let's focus on how we do play around with Spanner. And there's one important concept in Spanner which I wanted to share during the demonstration. So we'll do all these things once we come back from a break. So take a 10 minutes break and come back, folks.
This conference will now be recorded.
Now, before we do the demonstration, right, of Spanner instance, I thought let's do a small activity together where we create a cheat sheet uh, about the various resources which we have learned and what's their availability in the location, various, whether they are a regional resource, zonal resource, multi-regional resource, all those things. So I thought let me do that. That's going to work as a very good cheat sheet for you not only for the exam, but also while real implementation, when you're creating architecture, whenever they say it should be a global presence, what should be the product you should use. So you'll get an idea there. So we'll do that small activity, then we will jump in. So I'll directly put that into the uh, cheat sheet folder so that you should see it live directly. So I'll create a spreadsheet. So I'll call this as GCP services. GCP service. Oh, not a, so the service name is what I'm going to add. Service name, whether it is global resource, multi-regional, dual regional, regional, then dual zonal, or zonal. This is what we are going to add, folks. And the products which we have learned so far, we are going to add it right now. So let me just make it a little bold. Bold, make it. Okay. So that's the name. So maybe if you want to add a column to the left, the services, the number of services, you can keep a track of that also. The first service, compute engine. I'll add the services. Now you can also use this as a recap for you. So compute engine, Google compute engine, GCE. We'll also try to put the acronym so that people will get used to it. So the next product, anybody wants to comment? Google Kubernetes engine. People who joined late, what we are doing is we are trying to create a small spreadsheet where we are going to add all the services which we have learned and what are their presence, whether they are global resource, multi-regional resource, or uh, regional resource. That is what we are going to do basically. So that's going to help you out. So Kubernetes engine, GKE. The next product, folks, Google App Engine, GAE. Cloud Run, CR, Cloud Functions. Then we saw Google Cloud Storage. Then Google Cloud SQL Spanner, Cloud Spanner, Google Cloud Spanner. So these were the products which we saw. Now, your turn, folks. compute engine, whether it is available global, multi-regional, regional, dual zone, this thing. I need your answer here. So it is possible. So I'm just going to add S here so that you can have that. Dual zonal, is it possible? Dual zone, not possible. Zonal GKE, yes, Anil and Anil Kumar, Anil B, and Vivek. So is it possible to have a regional level? What is the option? What is that option? Yes, you can have it as MIG. Yeah. So with the template, with your managed instance group, you can do it. Dual region, again, it is going to be your dual region also possible, I would say, if it's going to be a MIG. So as long as it's so I can have it in Singapore and Mumbai, there's no problem, right? But it's going to be with the help of MIG and load balancer is what you have to play basically, is what I would say. It's not a built-in capability as such. The product is not uh, regional, dual regional or multi-regional. So basically you can make it with the help of templates and manage instance group option. So I just highlight this. I can also put I'll freeze these two columns. Two columns. I'll put some comments. Basically, zonal. So I have put that. So uh, does it make sense, or you feel it is not come? Actually, is zonal only. With MIG, we are making them. Yes, that is what we are trying to do. So we can. So I'm going to make it as naturally, whether it is zonal, and if we can make it multi-regional, regional is what I'm going to add it here. So that's the reason I'm going to add this S with MIG. MIG plus load balancer I'll add, folks. Global load balancer. This is, I would say, artificially made. I would say it cannot be global. I can make it all 24 regions. That is possible. Uh, Zonal by any chance? Dual zone possible by any chance, folks? By any chance possible? Think about it. Think about it. Kubernetes engine. Kubernetes engine. Possible. What could be the way we are going to do it? Okay, when it comes to Kubernetes, when it comes to GKE, it can be zonal. Good. Dual zone. Dual zone is possible. Let me check it, folks. Spreading of the nodes in the cluster across two zones only. When I make it zone, dual zone. Okay, lots of comments, folks. 1 minute. Let me just finish this and then come back. When I make it as zonal, The same node can be deployed in each. I can select. Okay, it is possible. GKE is possible to have my stuffs. So GKE is possible there. Regional, we have a direct option to do it. You don't need to do anything extra. You just click on regional. By default, if you make it regional, it's going to be a regional Kubernetes cloud. So regional is possible. No extra knobs required. You just directly do it. It's going to come up. You can have dual regions if you want, but you have to use something called as a multi-cluster. So that's going to be again an extra work which you have to do, something called as, yes, but you have to have something called as multi-cluster ingress. So if I just scroll this, there's an option which is possible. If I just show you, you have multiple regional Kubernetes cluster and how they can communicate each other. If you have multi cluster ingress, you have multiple Kubernetes clusters. So there's a nice diagram, not this one. Exactly like how we did with our MIG, you are going to use it here also, something like this. You see here, you have a regional Kubernetes cluster in US West, in Europe West. You use your load balancer, same IP, you are going to route the traffic here. So this is possible. This is possible. So you can have a dual zone or multi zone. So I'm just going to add a link to this if you want to refer to. And to be very frank, we have not discussed this. But it's on the similar lines how you use a load balancer. You have two Kubernetes cluster and do it. So basically, so even for your multi-region, it is going to be possible. It cannot be global because behind the scene, it's going to again use virtual machines. It cannot be global. App Engine, folks. App Engine. Dual zone, I will also add it here. Dual zone, I cannot do with MIG, folks. Okay, App Engine. Okay, first let me finish. Okay, App Engine. App Engine. Now, what you can do as a hint, right? After we do this, you are going to have a copy. You can keep it and you can have an up-to-date information. The best option to rely on this for is, I would say, use your locations, regions and location option. That's going to give you the best option. So if I just go here, many people don't scroll till the bottom. So if you see here, you can see the stuffs in Americas, like for example, multi-regional resources. What are the multi-regional resources? You'll get an idea. Similarly, what are the resources which is available in a specific region? You can get an idea. So this is going to be a good choice, basically. So if you look into that, the regions and location, App Engine is only regional, folks. It's not zonal. It's not dual zonal. It's only regional. Simple. That's it. Full stop. And you cannot have dual zone, all those things, because in one project you can have only in one region. So nowhere, no other option. It's not a global resource. Please note that. Simple option, regional. That's it. Full stop. Now, before we go further, right, I'll just add it here, right? Somebody was mentioning dual zone is possible with MIG. If I just go to my MIG, I don't think so it is possible, but unmanaged is possible. We have not looked into the unmanaged demo. If I make it as instance group, instance groups, create an instance group, managed. Now I can make single zone, and if I make it as multi-zone, it is usually 3 zones. If I uncheck it, they give a recommendation. So if you want to go against the recommendation, this is one option. This is just a recommendation. It's not that they're not going to provision it. If you want, you can go, but this is against the recommendation. This is one option which you can use. And you can also use something called as unmanaged instance group, where you create multiple unmanaged instance groups in different zones and join them with the help of your load balancer. So 2 options is what you can do if you want. So I'm just going to add it like this. Yes, MIG with load balancer. Yes, unmanaged with load balancer. So let me just slightly reduce this font. Okay, so I'm going to call this in red, indicating it's not recommended, so that you know that. I can add a comment if it is possible to add not recommended. Uh, by Google, so that you have that info. And this is going to be a Excel sheet in a readable form, so you can also see the comment. Cloud Run, folks. Cloud Run. You can look into the documentation which I again mentioned. So, or if you don't get it, simply go quickly to your Cloud Run and see what is the stuff it's going to show. What is that it is going to show me? So if I go to Cloud Run, it's a regional resource. It's a regional resource. So it's a regional resource. It does not show anything at zone. So yes, it is going to be a regional one. It's not zonal, dual zone, or this thing. I'm going to make these things no. Cloud functions, folks. If you can quickly go do it and let me know. Cloud functions. Folks, cloud functions, Google Cloud functions. You don't need to do much. Just go to your console. Yes, Anil B, that's correct. Waiting for others to also comment. Go to your cloud functions. Yes, Aman. So, yes, Mangesh. So it's a regional resource. So if you don't recollect it, just go and see. It's going to show regions only. Regions only. So no, no, uh, no, yes, no, no. So those are the compute options which we had. So those are the compute options. Going to our storage options. Is it a global one? Google Cloud Storage. No. Uh, is it going to be global? I would say no. It's not a global resource. It can be multi-regional, dual regional, or dual region, or regional. It cannot be dual zone. It cannot be a zonal. It can be regional, multi-regional, and also dual zone. So if you just go to your storage, classes, yeah. If you just go to your storage, right? Just to reiterate, if I put it here, so you see it can be a multi-region, meaning US, Europe, Australia, Asia, dual region, limited, but there are possibilities. And regional, all the 24 or 25 regions are going to be there. So I'm not sure whether the 25th region is there. It should be 20. Europe Central is also there. All the 25 regions are there. So it's going to be the three options: multi-regional, dual regional, or regional. Storage, Cloud SQL, folks. Cloud SQL. Cloud SQL. No for global. No for multi-region. No for dual region. No for this thing. So I can make it as dual zone. Regional it is not. How it can be regional? It is not span across all the three zones, right, Mangesh? It can, the failover is going to be failover. Failover is going to be in another this thing. So zonal, it's basically when you create your resource. Yesterday we saw, right, it was in Singapore A zone, Singapore B zone. It's a virtual machine at the end. Dual, the why I mentioned dual is the failover is going to be there in another zone, but in the same region. So failover in the same region. In same region. Okay, now we have the stuff. So Spanner we have not explored it. We'll come back, and once we explore it, we'll update this Excel sheet. So now let's go to the demo. So Spanner, click on the hamburger menu, go to your storage and databases. You'll see Spanner. You'll see Spanner. So the Spanner API is not enabled, but one important thing to note is Spanner is a managed, mission critical, globally consistent, and horizontally scalable system. Now, these could be some keywords, folks, at least from the exam perspective. These are really keywords. So I'm just going to put this in the cheat sheet so that if you see anything like this, uh, to be very frank, not much questions comes from Spanner is what I have seen. At least now the beta exam, maybe after they refresh it, they may have it. But in my two exams, the recertification and the first one, I have never seen questions on Spanner basically. But nevertheless, we be prepared for it. I'm just going to add a small tip in the exam stuff. Yeah, so the tip is If you see any word like this, is a managed mission critical. These are the some words, folks. Usually they use globally consistent, horizontal, scalable system. So if you see anything in GCP to fulfill all these things, the only product which can do is Spanner. That's it. That's it. So let me enable the API. And as I mentioned before the break, it's your call whether to use this or not. If you don't want to use it, don't even enable the API. And you can use this as a point also, folks. Say, for example, in your organization, there's some good amount of DBAs, and you don't want those DBAs at any cost to explore Spanner because the product is expensive. What you can do is disable the API. If you disable the API, nobody can access it unless they have a right privilege. So usually owners or Spanner admins only can do enable the API. So if you don't give them those kind of access and disable the API, by default the API is disabled, so they will not get access to it. So this is also one way. The APIs itself, you can use it. If you disable the APIs, the access can be blocked basically to that resource. So Spanner is a fully managed relational database service that offers transactional consistency and high availability at global scale. To use Spanner, create a Spanner instance within your project, set up your development environment to access Spanner so that you can add data. So this is also a good line. I can add it one more time. These are some keywords like which will definitely help us. So fully managed, we can add this, we can modify this. Fully managed relational database, mm, that offers transactional consistency. Very precisely mentioned. Global transactional consistency. Yes, it's a relational database. It's a relational database. Sorry. Uh, relational. I always make this mistake. Relational database. Mm, consistency, high availability at global scale. It's a relational database and you'll see it in action now. So let's create an instance, and because it's a Google product, right, you will not see that delay like how you saw in Cloud SQL, 7 minutes, 8 minutes, like that. You'll not see it. It's going to be super fast. So let me create it as batch 6 Cloud Spanner. The moment I give a name, it's going to create something called as instance ID. Now this instance ID is the one which is going to be used by the developers to connect to this Spanner instance, folks. In Spanner, you are not going to have an IP address, a port or anything. It is going to be an instance ID. Please remember it. So if somebody says, give me the credentials of Spanner, the only thing which you can give is the Spanner ID, instance ID, and the project ID. That's it. So they have to connect it. So you have to go on to use basically a service account, which is going to have a role to read Spanner stuffs. There's no IP address or anything which exists for Spanner. Okay, so now you get this option. Spanner is a regional one. So after enabling for API for Spanner and not create the same, will it cost? No. If you have enabled the API and if you have not created anything, nothing is going to incur. Enabling the API will not cost you. Only when the resource is provisioned is where it's going to cost you. So Spanner is basically a regional and a multi-regional resource. Let's update it. So let's make this as a habit so that we can keep it note. So Spanner is a multi-regional resource, not a dual, a regional one. Zonal is no, so this is no, and global no. So if we make this as a habit, right? Every time we learn a new product, we add it, it's going to be up to date. So why to go till the last day and create a cheat sheet? So it's a regional one or a multi-regional one. Let's go with the first regional one and understand it and then jump into multi-regional one. So when I select multi-regional one, I get the list of regions where I can do it. So most of the regions are going to be there. Most of the regions are there. And if you see the newly created region, Europe Central 2 is not available. Oh, Warsaw, it is there. Okay, it is there. It's Warsaw. Okay, it is there. Good. Warsaw meaning Poland, if I'm not wrong. So Poland is the 25th region. Okay, as Vivek mentioned yesterday. So I can see an official answer here. So it's Poland. So most of them should be there, but do we see anything like West of Frankfurt? Everything is there. Good. So one way to see whether it is available across every region, the best way I can do is look at this sheet, folks. Some resource sometimes are not available in a region. So having that is going to be really helpful. So for example, in Americas, if I go to Spanner, you see everything. So in Americas, it's available. Then if I go to Europe, Spanner is available everywhere in Europe. Awesome. Asia Pacific. Awesome. It is available in every region. Previously, it was not available. So now it is available in every region if you were to use it as a regional resource. So all the 25 regions are there. So I'm just going to make it in Singapore. Or if I put it in US Central, I can use US Central also if you want. The only reason if I use US Central, look at my cost, folks. Per hour billing, node cost, storage cost per GB per month. So node cost is going to be little expensive. The moment I make it as a regional one, you also see 3 read-write replicas in 3 separate zones within the region of US Central. So I'm going to have 3 read-write replicas, not read-only replicas, read and write, all in 3 zones. So meaning in US Central, you are going to have 3 zones. So in all the zones, you are going to have 1 replica. Totally, you are going to have 3 replicas. Meaning even if one zone goes down, no problem. My data is going to be there in the 2 remaining zones. I can still continue working. That's how I can get an SLA of 4 nines. So is this part clear, folks? If it's regional, you are going to have any regional spanner instance, you're going to have minimum 3 read-write replicas. Not like your Cloud SQL instance, where only one master is going to be there. So now you are going to have 3 masters in very, very simple terms. Okay, so that's US Central. And if you prefer to do something in close to your region, something like, say, for example, if I use Mumbai, the cost is going to be little high. Anyway, we don't want to incur too much cost. I'm going to do it in US Central. The US Central, if I do, it's going to be 90 cents. If I do it in India, it's going to be $1.26. So to reduce the cost, let me see whatever the options are there, basically. So this is the stuff. The storage cost is going to be this much. Now, by default, you are going to have one node. One node is what you are going to create. It's a one node spanner instance. So the maximum storage which you can go with one node is 2 terabytes. So this is where I mentioned, anyway, you cannot have a Spanner instance without one node. You cannot have, without a node, you cannot have a Spanner instance. Anyway, you're going to have one node, means why don't you utilize the full storage? So that is where I made a small thumb rule there. If it's not more than 2 terabytes, don't use Spanner. Meaning at least you should use one node. And if you are using the node, use it completely. Use it completely. So that was the reason why I made that thumb rule, folks. So 2 terabytes, less than 2 terabytes, it's not a good fit. At least make it 1.5 terabytes or something. Okay, so that's your regional one. And there is a small node guidance which they give, which is a recommendation. So for optimal performance of this configuration, we recommend provisioning enough nodes to keep high priority CPU utilization under 65%. Note the Spanner performance is highly dependent on the workload, schema, design, data set. The following best practice. There are some best practices which a DBA can look into for better best practice. So one thing which you need to be aware as a cloud architect is uh, the CPU utilization should not be more than 65%. This is a recommendation, folks. You can go beyond it. If it goes beyond it, and if you raise a ticket to the customer care, to the support will first look into this. Have you followed this? If you are not followed, they will also say, please do this. Add more nodes so that your CPU utilization comes down. If one node is there, if the CPU utilization is, say, for example, 80%, if you add a new node, the CPU utilization is going to drop to what? 40. It's going to get distributed. So you need to make sure the utilization is not more than 65%. How do we do it? There are few tools in GCP which we can use at a later point of time called as Stackdriver or cloud operations. We'll explore that during that time. But this is a recommendation which Google gives. So that's your multi-region option. I'm not going to click on create because we have not explored regional one we have explored. Let's explore the multi-region option. So if I click on multi-region, you have limited multi-region options. Not every or you don't have multiple options there. Very limited is what you have. So the first option which you get is Asia 1, where you are going to have in Asia 1, Tokyo and Osaka, both are in the same country. So if I just go to my, it's basically in Japan. Basically in Japan. So you are going to have, there are two regions. So soon, I guess in India also you will have two regions basically. Delhi is going to come soon. I'm not sure when. When it comes, there's a chance that we may have a multi-region or at least dual region in very simple terms in Spanner instances. So one which you have is Tokyo and Osaka in Asia. And the most important thing which you should look here is this one, folks. SLA is 5 nines. 5 nines. So what you are going to have is basically two read-write replicas in Tokyo, two read-write replicas in Osaka. So totally 4 read-write replicas are going to be there. So there's something called as a leader region. So where most of the stuff, so it's going to be the leader. So there's a concept called as the instance is going to find out who's having the latest data up to date. It's going to become the leader. Basically, there's a concept like that in Spanner. So this is how they do dual region or multi-region, to be very frank. So, and I was doing this to I was doing a training to a small organization. So there was a person who did a technical joke on this when I was showing Spanner. The joke was both the cities are both the places are always prone to volcanoes. Earthquake. Tokyo and is also, and Osaka, both are this thing, but they have a region there. So meaning they could have definitely built the data center to withstand those calamities, basically natural calamity. So that's the only option which you have currently in Asia, folks. There's no presence of Spanner as a multi-region in Asia. So this is very important. So Say for example, if you're going to propose this to a customer in Asia, it's going to be a little tricky. You can prefer to use as a regional one, but it cannot be multi-regional. Remember it. And when I make it as multi-region, right, the price is going to double or more than double. It's going to increase that. So similarly, you have few other options: Belgium and Netherlands, London and Belgium. So usually it is dual region. If you ask me, sorry, dual region also, it looks like we can add it here, folks. We can add it dual region also, but they still call it as multi-region. So there are possibilities, and then you have few options: North America, Europe, Asia. So if I just select this one, you get a slightly different configuration here. What is this? You're going to have two read-write replica in US Central, two read-write replica in US Central 2, which is a private GCP region, two read-only replica. Now the concept of read replica comes in Belgium, two read-only replica in Taiwan. So if you want a global presence kind of a stuff, the best option which you can use is this one: NAM Euro Euro Asia 1. That's going to be the best option. All other options will be either in one specific continent, like North America 10. It's only between US Central and Salt Lake City. So most of the time it is dual region, folks. There's only one which is truly multi-region, more than two. Okay, so but if it's a read only for other region, yes, that's the limitation which they have currently, Kumar. So it's not, you're not going to have a read write replica in all three regions, but at least if it is a dual region, right, dual region, you have read write in both. But if it's more than two regions, you are going to have only read replicas only. So maybe in the future they may change this, but this is the current stuff. So the why I'm sharing this information is, when you're designing it, you need to decide, okay, whether this is going to really fulfill my requirement or not. Just saying it is multi-regional, horizontally scalable, but there are certain stuffs which you need to know as a limitation here. Okay, so now going back to regional, because I don't want to create a multi-regional one, it's going to be expensive. So I'll choose Singapore, or I can choose I'll choose US Central, folks. US Central, which is going to cost me $0.09 per hour. Click on create, and it's going to be super fast, folks. Click on create. Next few seconds, it's going to be there, not minutes. Done. Instance is created. You see the value of having a native service versus something which is more open source kind of a stuff. Instance is already there. It's already there if you just see it. Now this is where my billing starts. Now if I just leave it and immediately delete it also, I'll be charged 1 or $0.9 because it's a per hour billing. It's a per hour billing. So the instance is ready. Now inside the instance, like how you created databases yesterday, world database, bookshelf, like that you can create a database. So let me create a database, and I can create up to 1024 databases. In MySQL Postgres, for that you have to look into the MySQL documentation, Postgres documentation. But in a Spanner instance, you can create up to 1024, and each database can have 2000 tables, folks. So they can have 2000 tables. Sorry, this is just for your information. If you want, keep it. So it can easily have good amount of databases running. Let me create a database called as something like, what should I create? Entertainment. There's a disk 2 TB per, no, it's not 2 TB per DB, it's a node. One node, in one node you can have n number of database. The node size is 2 terabytes. The maximum one node can take is 2 terabytes, basically. Entertainment. So that's the database name. I'll just create the database first. Deepak, hope that answers your question. It's the node, not per database. It's at the node level. So the database gets created in those nodes only. Now I have my database called entertainment. Now what I'll create is I'll create two tables, folks. A singer table and the albums which the singer creates. And this is a demo or this singer and album concept, right? Or this stuff is also mentioned in the documentation. I'm just relying on the documentation which I read. So I'm going to create a singer and a album, the singer, the albums which the singer created. So let me create a table, and there are some new stuffs which they have created. So now it supports foreign key. Now it supports multiple versions of query optimizer. Lots of new stuffs which they are keeping. So this is a good way if somebody wants to explore Spanner, they can explore this. So we are not going to do those many advanced stuffs, which is going to be helpful for a DBA. Now I can create a table. So one way you create a statement like this, which most of us may not be comfortable, create a table, that kind of a stuff. If you were to do that, I have it in my cheat sheet. You can refer to that in the Spanner. You can just go create it. If you don't want to do that, I'm just going to basically in a different style, just turn this off. I'm going to get a UI where I can directly enter the details one by one. So singer is the name of my table. Click on continue. Now it's going to ask me the columns. What are the columns you are going to have? Basically, I'm creating the schema for singer table. So the first one, I will add it as first name. The name is going to be basically, these are the available data types. It's going to be a string. Done. I want to add one more this thing, last name. Again, string. Then what else? Maybe I can add singer ID, which I'll make it as primary key. Singer ID, I'll keep it as integer. Good. Any other columns I should add? Singer ID, first name, last name, singer info. Okay, singer info, not required. So these columns should be good enough. So singer ID, first name, last name. That's it. Continue. Now, if there's any table, there's going to be a concept of primary key, using which I can query it faster, all those things. So, and it's going to create something like unique. So there's no duplication, all those things. That's where primary key comes handy. More of a database concept. So, and this primary key can be on a single key or a combination. Two keys you combine, then it's going to be a primary key. So this is the first time we are doing it. Let's not make it so complicated. Let's have a single key or a single column. So I'm going to use singer ID as my primary key. So, and it should be always unique. That's it. What I did, basically created a table, then gave 3 columns, and I made one column as a primary key. That's it. Click on create. The table gets created. This is basically the DML statements which we did. DDL statements, data definition language. So I have the stuffs. Good. I have the stuffs. That's good. Now what I will do is go back to my database. There's one table already there. Now I'm going to create one more table which is going to indicate I want to capture the details of this singer. What are the albums this singer has created? So again, I'm going to use this information like where I can directly type the stuffs albums which this person has created. Now, for the first time when you created the table, this option was not even showing. Interleave in another table. What is this interleave? Is an important thing. Now, this is an important distinction which you get with your other relational database, because other relational databases are usually vertically scalable. Everything is in one system, but Spanner can be spanned across multiple nodes, right? Now, this interleaving is going to help you speed up the queries. What does that mean? Basically, if I just do a small example here, assume I have a 2-node Spanner instance. Node 1 is having single table. Node 2 is having album table. If these two tables are there in two different nodes, right, and singer and album actually always going to be queried together. Get me the singer name and also get me the albums which the singer has done. So this is how I'm going to do. So I'm always going to do a join between these two tables and query it. So when I do this kind of a stuff, right, the data has to be read from two different nodes. So there's going to be network latency. So to avoid that network latency, what you can do is, when you are designing it, make sure both the tables are interleaved. That's the term which they use. Make sure they are configured in such a way that they are always in the same node. They reside in the same node. That way, my network latency, the disk read, can be reduced to a great extent. If it is in the same node, it's going to be easier, right? So that is where this concept of interleaving comes into picture. First time when we created a table, it did not show because there was no other tables. But system automatically identifies there is one table already there. Maybe that table and this table you are going to query it very often. So why don't you interleave with another table is what it is saying. So if I say yes, I want to interleave it so that I can improve the querying, I can query speed, I can increase. It's going to ask what's the table with which you want to interleave. I want to interleave with singer. Fortunately or unfortunately, we have only one table. And you can also turn this optional option called as delete parent child row, cascade delete. So if there is no singer, having the singer information, the singer album is of no use. So if you delete a singer, delete the albums which the singer has created. That is what I'm saying with this option. But this interleaving is the important concept, folks. Something very unique, which we would not have seen in any databases. There could be in AWS, there is one database called as Aurora, which is somewhat equivalent to Spanner. But in normal on-prem, people would not have seen something like this. So like horizontally scalable systems. So this interleaving concept is something new. So click on continue. Now, the moment you make it as an, it has to be interleaved, automatically you'll have a column, which is nothing but the primary key of your parent table. So this is not a foreign key, primary key relationship. That kind of a stuff you can also do. That is a traditional way. But here we are doing it between two nodes so that we avoid creating the stuffs in two different nodes, but have everything in one node. Because these two tables are going to be always queried together. They're not going to be always queried separately. If there are tables which is going to be queried separately, we don't need to have any interleaving concept. So hope that is clear, folks. So this interleaving, at least if the database, now maybe you may be working with a DBA, he would have come with something like Oracle background. In Oracle, they would not have used it. Now, as a cloud architect, you need to suggest this. So there's a concept called as interleaving. Please explore it and decide how two tables needs to be queried. Based on that, you need to turn it on. At least a word of mentioning this is important. That's where having a small exposure on how this works is going to be helpful. That's why we are doing this demo. So because it's an interleaved, so it's going to capture automatically the primary key of my parent table. Let me add two more columns. Album ID, done. Then album title, the title of the album, which is going to be a string. That's it. Now when I continue, I don't have any option of single column. it automatically makes it as a composite, and it is between your singer ID and another column which is there in your table, which is album ID is what I'm going to use. So it's going to be a composite key. So in the first table we saw single column. In the second table, because we interleaved it, it's going to have a composite key. That's it. You go and click on create. Before I click on create, I want to show you the SQL equivalent of it if you are interested. So this is going to be a SQL equivalent. Create table, primary key is a composite key, and you have also turned on interleaving with single table. Go ahead and click create. Table gets created. Once it gets created, we'll just manually insert a couple of data and see how it works. Now onwards, it's going to be basically a normal database style. You insert rows, update rows, all those things, because it's ANSI SQL compliant. So all your SQL knowledge will be still used here. Now what I will do is I'm going to insert some data, and I'm going to take a stand of a data person who is not so comfortable with database. If a data person who is not so comfortable with database, how will he insert the data is what I'm going to show you. If you're comfortable, usually use a simple command, insert into table name values. You can directly insert it like that. For a person who's not from the database background, the way I can add it is data. I can insert it in a UI. Let me insert a couple of rows. So singer ID 100, singer name Will Smith. Done. First singer information added. Let me add one more singer. Singer ID 1.101. Johnson. That's the second name or the last name. I'm just making up names, folks. There are two singers there. Good. Now what I'll do is I'll go to my album table and add a row, couple of rows. So let me insert this. So singer for Will Smith, I'm going to use this one. That's the singer ID. Album ID 1. What was the album which this person created? Blah, blah, blah. And that's the album name. Or two more. Same singer. I'm going to add album ID 2, Twinkle. Added. One more entry for the second singer. 101 is the singer ID. Album ID is 3. This is raw. That's it. Now I have 2 rows in single table, 3 rows in album table. Now I wanted to get a complete list. Get me the list of the singers and the albums which they have done. So if you were to do something like that, that's where you're going to do a query. Let me just click on query and query it. So I can just put a query, select. This is going to be a little tricky if you're not coming from the background. So I just wanted to show you, you can query it. That's it. And also wanted to show you that all your SQL knowledge, if you have an exposure on SQL, your SQL knowledge is going to be still helpful, is what I wanted to show here. And if you're not from the database background, no worries to run this demo. Okay. So I'm going to call S is an alias. So because I'm going to join between two tables, I want to create an alias. So singer, sorry, first name, comma, S dot last name. What is S? I'll tell you in a minute. It's an alias. A dot album name. From, I want to do it from two tables. First table is singer and the alias is yes. Then albums, okay. A, those are the alias, folks. A dot album. Where I put a clause. Why A dot is not coming? What is the name of the album? Album name only, right? And put a where clause where I do a join between the, it's an inner join. So singer ID. I have to look into the table schema, folks. I don't remember whether it is singer ID or singer underscore ID. What I gave, I don't remember. Let me just look into it. Singer ID, okay. Then the other table, albums. What's the name which I given? Album title. Okay, it's album title. That's the reason it was showing error here. Okay. Singer ID equal to A dot singer ID. That's it. Should be good enough. Let me see. It's showing error. What is this error? What is the name which I've given? Album title. That's good. Albums is the table. A looks good for me. Let me try running and see. I'm not getting this error. Let me see whether I can get the error when I run it. Okay, I don't know what is this error. Maybe I'm not sure, but I'm getting a result here, folks. I got the result in 4 milliseconds. It was only totally 5 records in our system. So first name is Phil, second name, the last name is Smith, the album which the person created. So this person has created 2 albums. The second person has created only 1 album. So basically the whole intent of showing this demo is if a person knows has a SQL knowledge, they can leverage Spanner. Maybe you are an expert in Oracle, assume. Now you want to have a upgraded skill in GCP. You can position yourself as a cloud architect plus an expert in database migration. So if you know Oracle, definitely learning Spanner is going to be a piece of cake for you. I've seen this many times from the learners in the various batches. So they had selected this as an option. So database migration is your expertise, and you can also create architectures. So position yourself as that if you are looking for some new jobs. So that's basically the demo on Spanner. Last one thing, let me just show you. What I'll do is, because we have turned on cascade delete. So if I just go and delete, if I just go and delete entry, what's going to be is if I go to the data, if I just delete this Will Smith entry, what's going to happen basically is, because I have turned on cascade delete, this action will permanently remove the selected rows along with any child rows in the table that have cascade delete turned on. So meaning my album details, the 2 albums, blah, 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 and Twinkle, Twinkle is going to be removed automatically because I have turned on cascade delete. Want to wait? Just go to your album tables. You should see only 1 row, only the singer 2, which is Johnson. That entry is there. It's not there. Remaining everything is going to be deleted. That's your cascade delete. So let me just stop here, folks, for any questions on what we did. Basically, this was more of database, but wanted to show that people with database skills can use it. Maybe somebody is going to ask you as a cloud architect, say for example, I only know Oracle, I only know MySQL, I don't know Spanner. You can easily say that if you know SQL, you can use Spanner. You already know it. So at least to say that message, I showed you this demonstration, folks. Because they expect many things from architect. So having exposure everywhere, even at a high level, is going to be helpful for you. Any questions on Spanner, folks? So it's not supporting triggers and store procedure. Yes, it's not supporting. At least the last time when I saw it was not supporting. So need to see whether they have started supporting it. But currently it is not, is my understanding. They don't support store procedures and triggers. If you were to do it, you have to write it in the application layer, not at the database layer. Any other questions, folks? Now we spent to at least around 30 minutes slowly doing. So one question. We have regions like NAM3, NAM6. How do they name how do they do the naming convention? Okay, that's a simple one. So the first one which gets created is going to be called as NAM1, something like that. So if I go to my multi-region, you see the spanner. You have NAM3, NAM4. I don't know how they create it. They give the naming convention. Don't have an exposure on this Anil B. So I'm not sure whether it's random or they have some logic behind it.
Actually, within the NAM3, they have mentioned 2 states, right, or 2 regions, and with NAM6 they have 3 or 4. That was the if you look into
NAM6 is there.
Yeah, can you click on the NAM6? It will say, it will show you 3 or 4 parts. Asia is there, Europe is there, something. These.
No. NAM6 is only Central and South Carolina. Only 2.
Okay, maybe I can. Okay. Okay.
So only when you see NAM, right, it's North America. That's it. Only when you see NAM, Euro, Asia, then it's going to be all 3. So 3 continent, the only option which you get is in 3 continent is this one. This one. NAM, Euro, or Asia 1, where it spans across all 3 continents. Remaining all is within the same continent, either in Asia, either in North America, or in Europe. These are in one continent. These are all one continent. Hope it's clear, Anil B. So now if I don't have any questions, I'm going to do is, I'm just going to delete this, folks. So we already spent around 30-40 minutes. It's okay because anyway the billing is per hour. So I'm just going to delete this. So we don't need this anymore. And the developers always access this via the ID, Spanner ID. No IP address, nothing. ID. Can we say multi-regional is, can we say same as global? No. In GCP, you have something called as global resource. We have not seen a global resource till now. We will see it in our networking class, in our big data class. There are resources which is global, truly global. So we cannot say a multi-regional as global. There are few products, networking, PubSub, these are global products. BQ is not this thing. VPC is a global one. PubSub is a global resource. BigQuery is a multi-regional one or regional one. All right. So good. So that was a demo on Spanner. Now, before we just wanted to highlight something on Spanner. This is a problem which you get always in a horizontally scalable system. This is a known problem called as hotspotting. What is this hotspotting? First, let's try to understand it. So, and this diagram is something which I got from Google, but maybe now it is removed. So there are nice images, they keep it, but I don't know, for some reason, the content gets updated. So long time I had this content, it was there in the website. But they have removed it now. Maybe it is again restored back, but once I saw it was not there. So what is this hotspotting basically? The basic thing is you have n number of nodes. So just treat it as n number of nodes as n number of employees in the organization. Okay, n number of employees in the organization. So you have a just an example, folks. Okay, so there's a team A. In this team A, there are 10 people, 10 developers or DBAs, whatever it is. So in that 10, right, there's only one person who's very smart. Now, what's going to happen if a person is very smart there? All the task is going to come to him only, most of the time. Now, when it comes, what is going to happen? He's going to get overloaded. So when he gets overloaded, there's a time the system can crash. Similarly, this person may not be working optimally. This is the same thing is going to happen even when you do the same concept applied to horizontally scalable system. So in this case, the table schema is something like this. There is a composite key where the last access time and the user ID is the composite key. This is how they have designed the table. Now, if this is the combination, assume this is a system which captures user login. Maybe because most of us work from home, there are few organizations who create certain policies. 9 o'clock in the morning, you should log in to the VPN, the corporate VPN. That's how we can see your uh, attendance, or you have logged in, you are in the system, something like that. At 9 o'clock, many people will log in. So if you see here at this timestamp, there are many user IDs who is logging in. Now the design is really bad. Why? The first few letters are always, or the few combination is always going to be the same. So what's going to happen usually in a horizontally scalable system, if the rows or the primary key is monotonically increasing numbers, 1, 2, 3, 4, 5, like that, or it's in a increasing time stamp, this is called as monotonically increasing. So what is going to happen is all those things, if it's a sequence, all the data is going to be written into the same node. It finds, oh, these are a very common data, so it's going to write everything into the same node. So if you see the pattern here, almost the last access timestamp is almost same for most of them. Everything is going to be written into the same node, even though it is a 5-node spanner instance. Every write operation is going to only one node, which makes that node hot. So there's a chance that this node may stop functioning properly. This is called as hot spotting. And you see there are other nodes which is not even working or not even being utilized. So what you should do in a typical horizontally scalable system is you should do something like that. Thing is that write operations should be distributed. This is rule number 1. Read operations distributed means different nodes. And when you're reading something, right, should be most of the time coming from the same node. Should be from the same node. This should be a rule which you should make sure it works in every horizontally scalable system. So write operation should be always distributed. So no one node works too much. No one node. So there should be no nodes which is not even working. So to avoid this, what usually people do is they make sure the design of the table is in such a way that hotspotting is avoided. How we can avoid in this case is simple. You swap your combination. Instead of using user last access plus user ID, use user ID and last access, because every user is going to be a unique, right? You are going to have an user ID, NT username for your laptop, for your corporate laptop, or something which is going to be unique across your organization. So that way, if these users log in at the same time at 9 o'clock in the morning, no problem. You see a sequence there. So 000. So if the user ID is starting with 000, it's going to be written into node 2. If it is 001, you see there are 2 entries with 001. So both of them are going to be written into node 4. 010, it's going to be written into node 5. So this way the write operation is distributed. Now, if a manager wants to know, let me know when this 010001519 user logged in. Get me the history of this user for the last 1 month. The query is going to go and get the details from node 4. Read operation should be always from the same one node so that you don't have any network latency, reduce your disk read operations, not reading from multiple disks. And your write operation should be distributed. So basically, if you can design, if the DBA can design the schema in such a way that hotspotting can be avoided, that's going to be a good choice. One of the tip for avoiding hotspotting is avoid monotonically increasing numbers. Have a hash or some kind of a global ID, which is going to avoid this one. So this is called as hotspotting, folks. So which can be avoided by a proper design. So meaning the indication is there's a role for a DBA to play. A database person has a role to play when it comes to schema design. That's hotspotting. And this is going to be an issue in any horizontally scalable system. Okay, remember that. So that's the end of our spanner, which is a relational database and horizontally scalable relational database. So we'll take a 10 minutes break. Once we come back from a break, we will look into a NoSQL database in GCP called as Datastore. And we'll also, okay, you want it in the chat. Okay. So you want to put it in the chat, I can put it. All right, so let's take a 10 minutes break, come back and explore the next one, folks. So take a break and come back.
All right, folks, let's continue. Let me start the record.